All right, it says to find all solutions in radians again, this time using the graphs of the trig functions. We can use the unit circle here, but it's just also good to connect to the graphs. So the graphs of cosine, the cosine graph is an iron condor, as we call it. I like it as kind of for fun. So where I'm looking is what angle, which x-axis angle is the cosine at -1, and that would be right down the middle of the graph, which would be at pi. Now, to get that answer to find all solutions, you'll see that it would happen again if I go the length of the period here would be, so like here's 2 pi, and then it would happen again at 3 pi. So basically, every 2 pi that I move, or the period is 2 pi, then I'm just going to hit the next answer. So the next one would be at 5 pi and 7 pi and so on. So I can just add the period, which is 2 pi, and n to represent all the solutions. Then for sine equaling 0, this is kind of a special case because here's the sine wave. We're looking at the x values where sine would be 0, which would be here, which is the answer is 0. And then here, which is pi, and here, which is 2 pi. And then the next answer would happen at 3 pi, 4 pi, 5 pi. Every pi in this case, I know that's not the period, but every pi, it keeps hitting another 0. So the answer here, I can just say 0 plus, and then pi n to say like every pi that you want, every pi you move, you'll hit another 0. So final answer, I don't need to put 0, just pi n. Now there's other ways to represent that, but that's really how the answer should look because that's the most simplified answer. Sine x equaling 1. So sine equaling 1 is up here, and this is 2 pi here, it's pi here. So 1 is pi over 2, and then I can say my answer is pi over 2. And then I won't hit 1 again until I get another graph drawn here. And so that's the period here from start to finish. It just repeats every time I move 2 pi over. So plus 2 pi n, and then every 2 pi after that, it'll hit again and again. So the answer here look like this.